This is section 1.1, and I will want you to go through and read this on your own. Just kind of talks about what we're going to be doing this year of applications that we will be doing. And then there are 4 sections in this chapter. This is the first section, functions and models, and here are the objectives. A little bit different maybe than your other classes. And then we're going to spend a lot of time in applications. All right, so what is your favorite vending machine item at Eastridge High School? So I'm just going to pick these as my inputs. So if I were to click B1, what's going to come out? And I'm going to say Skittles on the first one. I'm going to say chocolate on the second one, which I don't think there is any anymore. And then I'm going to say Skittles again, because if Skittles are popular, they could put them in 2 different ones. And then I'm going to say gum, which I'm pretty sure they don't have anymore. So can B2 have 2 candies? And this is a function scenario that I want you to think about. So if I were to do B2 and it was a perfect scenario where the person before you didn't get theirs, where it was partially down, so they walked away and then you put in, you got 2. We're not doing any like exceptions, but in a normal world, if you were to do B2, you could not get 2 different options. You couldn't get Skittles and chocolate. But B1 and B3 could put out the same output, as you see here it does. Oops, sorry. And that would get you Skittles. So that would be a yes. So if you take a look at these 2 scenarios here, it kind of defines a function for us where every input can only have 1 output. So this input has 2 outputs, but B1 only has 1 and B3 has 1, and they can be the same, but they can only have 1 output. And that's why this would be a yes. So if I were to go ahead and define what a function is, I would say every input has 1 output. So an input, another name for that would be an X. Another name for output would be like a Y. Another name for an input could be domain and range, just so you get comfortable with all 3 of those pretty much being the same thing. Please be sure you're taking notes, because you will be getting those checked for credit. You'll get points for these notes for taking them with me. So in other words, if I were to just take a look at what that would look like, just picture wise, I could have 2 X's going to the same Y, so that would work. And I could have 1 X going to 1 Y, that would work. But I couldn't have 1 X going to 2 different Y's. That would be a no, that would not work. So if you want to kind of write those down, good visuals of that. So a function is a relationship between 2 variables that can be defined numerically, graphically, verbally, and by an equation. So you can define this relationship in multiple different formats. Functions can be applied to help solve problems that occur in real-world situations. We will be doing a lot of these, and you'll get more and more comfortable as we go. So this is just a nice visual of a function machine. You input an X, whatever that is. The function does its work. Maybe it multiplies by 2, and then it subtracts 4. Maybe that's what it does. And then it kicks out an output. So whatever that function is, we'll convert it to an output. Okay, so I want to actually go through a couple more examples of functions with you. Function versus not a function. So writing a checkout, you can only write a checkout for a certain dollar amount. You can't write the same check 1001 out for two different dollar amounts. It can only be $1 amount. So that would be considered a function. And something that's not a function would be like the fall season could have 60 degrees one day and 40 degrees the other. So that would be an example of not a function. Another function would be if you were getting diesel gas, you would only pay a certain price. You wouldn't have two different prices for that one specific gas. One more example of not a function would be like if you had a Honda car. You could have there's more than one kind of Honda car. There's an Accord, there's more than these two. Insight. So it is going to more than one type of car. So these would be not functions, these would be functions. Okay, so let's talk about the domain. What is a domain? And remember, we talked about a domain, just talked about it in the other page. It's the X, or you could say it's the input, or you could say it's the independent variable. And a range would be like the Y or the output or the dependent variable. So if you think of my example that I just gave you, B2 would produce chocolate. So the independent variable, you get to pick whatever you want, B1, B2, B5, and this chocolate depends on which one you pick, is dependent on your pick. So this would be my independent, where this is my input. So I'm going to give you one more example here. F of x equals 2x. So my input would be my x. That's my independent variable, whatever I put in for my x. And I'm going to actually show it on this side. So I'm going to input my x. If I picked, for instance, 3, that's independent. I can pick whatever I want. And my output, my f of x, which ends up to be 6, depends on, that's my output. So I'm inputting a 3 and I'm getting out a 6. So my input, my x is my independent variable, and my output depends on my input. Let's take a look at some domain and ranges on graphs next. Okay, so I'm missing something in my notes here. Is this a function? So does every x have one y, or does every input have one y? And if you look at it, this one here would be -3, 1. This one is -1, 2. This is 1, 5, 3, 1, and 2, -3. So if you look at all the x's, so that's one way you could look at it. There's a quicker way, but I just want to show you this way first. For every one of these, the x has one output. So the -3 goes to the 1. The -1 goes to the 2. The 1 goes to the 5. 3 goes to the 1. And the 2 goes to the -3. And we could put that 3 here and have it go down to the same 1 if we wanted to. But still, every x has one y. So is this a function? I would say yes. Is it discrete or continuous? Well, you do not connect the dots here, so these are specific points. So I would say this was discrete. It's not connected, like this one is connected, so this would be continuous. What is f of 2? So when x is 2, so this is like the x, when x is 2, if you look at here, I'm going to go over 2, y matches with that with the output is -3. So f of 2 equals -3. F of -3, so when the input, the x, is -3, the output is 1. So f of -3 equals 1. And then I'm going to list the domain. So the domain are all the x's here. So we've got -3, -1, 1, 2, and 3. And then the range, notice when it's discrete data, it is a list of numbers. They're specific numbers, not the ones in between -3 and -1. It's just -3 and -1. And the range is going to be -3, 1, you don't write 1 twice, 2, and 5. So you don't repeat numbers in those. And I notice how I put them least to greatest also. Another way you can tell if this is a function is if you did the vertical line test. So if I made a vertical line here, oops, hang on a second. This one is what I wanted. And I took this line and I drug it. It passes a vertical line test. Notice it only goes over 1 point at a time. So I would say this is a function because it passes a vertical line test. So what if I added another point right here? If I added another point right there, I would have to say that this does not pass the vertical line test. Oops. Because right here, it's crossing both of those at the same time. So if I had that extra point in there, and that extra point is -3, -1, then it would make this not a function, because if you notice the -3, it goes to the 1 and the -1, and that would make it not a function. That x has 2 y's, not just 1. So just an example of it if it wasn't a function. Okay, let's go to the next one. Is this a function? So again, I would do my vertical line test. When I'm scrolling over here, the purple curve, it doesn't go over 2 parts of it at one time. So I could say, yes, it is a function. And I would say it's continuous because it's a curve that all the points are connected. And then I'm going to find f of -2. So at -2, where is this at? And I would say it's at -2. When the input is 0 or the x is 0, I would say it's at a +2. And then the domain is different because this is a continuous function, so it's not a list. And we could use interval notation or inequality. I'm going to use both, and we learned that in the toolbox. That's why we did it. That's why we did the toolbox. So if I was looking at the domain, I'm looking left to right. And if I notice left to right, I notice that this starts at -5, but it keeps going. Notice the arrow here. So I would say the domain starts at -5 and includes it, and it goes to infinity. And infinities or negative infinities always have the parentheses on them. So another way I could write this is x is greater than or equal to -5. If I ask you for interval notation, and this is inequalities. So depending on which one I'm asking, I could ask you for both. So make sure you're able to write both of them. Now, if I'm looking at the range up and down, so range is on the y, notice it goes to the 3, and then it goes down to 2.5, negative 2.5. So this is the range. So when I write that, I'm going to go from negative 2.5 up to 3. And notice I have the 2.5 because this is the least number. This is the greatest number. And notice I have brackets because it's including both of these points right here and right here. And if I was going to write this in inequality, I would say y is greater than or equal to negative 2.5 and less than or equal to 3. Lots going on in this page. Okay, next one. Is this a function? So again, if I did the vertical line test, oops. It's not a vertical line. Let me fix it. There we go. And I were to drag it across anywhere on here. Let's just take this for instance. Notice that it crosses in two different places. So I would have to say no. Is this a function? No. Because if you look at those 2 points, my x is 1 in both of them, but this one, my y is 2.5, and this one, my y is negative 1.5. So this x does not have one y. And so that would be not a function. And then f of negative 1, so when the input is negative 1, when the x is negative 1, what is my y? And it would be this 2 and negative 1. So this would be 2 and negative 1. And then f of 2, so if I go to the 2, when the x is 2, my y is 3 and negative 1.5. So it's going to be 3 and negative 1.5. If you take a look at this circle here, I would have to say no again because it doesn't pass the vertical line test. And f of negative 1, so when x is negative 1, this curve is at 4.5 and negative 3.5. So 4.5 and negative 3.5. And f of 4 is at 0. So then I can really say f of 4 equals 0. Okay. That was using graphs, doing inputs and outputs. So next we're going to go on to how to calculate domains or acceptable inputs. So in this first one here, I have these really specific for you, the 3 different scenarios that we're going to work with. I could put any x in here, any x I want. So if I look at the domain on this one, I would say you could write all real numbers, or if I wanted interval notation, you would say negative infinity to infinity. And the range would also be all real numbers or negative infinity to infinity. Let's take a look at the second one here. Now, if I'm putting an x in here, if you remember a square root, what I'm highlighting here, this has to be greater than or equal to 0. You can't have a negative under a square root. So I don't know what x I'd have to put in here to make this whole highlighted area equal to greater than or equal to 0. So I'm going to say 2x minus 7 has to be greater than or equal to 0. And if I solve that, 2x has to be greater than or equal to 7, or x has to be greater than or equal to 7/2. So here's the inequality domain. And another way you could do this is by saying it would include 7/2 and it would go to infinity. I'm just going to highlight the domain over here too. So either one of these works. Here, I know I did the range. I didn't need to, but I just put it out there anyways. So here's the domain of the second one. And let's take a look at the third one. So in this case here, underneath in a denominator, we all know that this cannot equal 0. So I need to figure out what x would make that 0. So I would have 8x cannot equal -3, and x cannot equal -3/8. So x cannot equal -3/8. If I put -3/8 in there, that's going to make the denominator 0. So if I ask you to put this in interval notation, this one's a little bit trickier. So I just want to show you what this looks like on a graph first. So I'd have my -3/8, and I would have basically an open circle there, and it would be everything except that point. So in other words, I have this range here, which ends up to be -infinity to -3/8, not including it, or it would be this part here, which would be -3/8 to infinity. So that blue there, this little U means or, you learn that in geometry. So this would be, if I asked you to write this in interval notation, this is what you'd write. And I will ask you to do that. So these are the same exact, they mean the same exact things, but this is the numerical part of it, this is the graph of it, and this is the interval notation. So I'll give you another one of these in your homework to practice too. Here is your homework. I have some specific directions, so my directions always trump the directions that are in the book. So 1 through 4, 7 through 10, 12, yep, do the directions on those. But when you get to 15 through 20, if it's yes, I want you to tell me the domain and range. 21 through 24, I want you to tell me why or why not you're saying what you're saying. And then on this last section, I want you to give me a list or an interval notation and inequality, depending on which one they gave you initially. And then these are your story problems, and I will have these done for you. So you'll be able to see those on Schoology. Homework is due the day of each quiz, if we have a quiz. I will check them the day after I assign them. So they will be random checks. So be sure that you have them done. Make sure that you're putting in your time on the day that I'm giving these to you. Homework needs to be complete to earn full credit and scored with work. If there's no work, there's no credit. 2 is the most you can get. It says all work shown to answer and on time. And a 1 if it's more than half done or late, turning in before the test. 0 is less than half done. And it's not turned in before the test on this one. And an M means that it was not turned in before the chapter test. You would get M equals 0 points. And after the test, you can't turn it in. So it would be very wise for you to get a 2 on your homework. You don't want to lose points on things like this, because you might lose points on the test or other areas or models or other areas. So please be sure you do your homework. And then during my video chats, you can ask me any questions on any